Hello everybody, my name is Epidemiology Quintana. I will try to explain how useful are the regular expression in order to handle databases. First, I will start with a motivating example. It's actually a thing that everybody knows how to do, is how to record a variable that is continuous. We have a variable age that is continuous, and I will recode in three categories. That is the elder, who are people that have more than 75 years old. The middle age, those who are between 45 and 75 years old. And the young one, who people who have 45 years olds or less. So actually it's the same thing that I actually mentioned before. You have age as continuous. Suppose actually people go from, sorry, it's wrong here, it's 35 to 85 years old, and actually we divided in these three different groups. This is the code actually how it looked like in R. It's very simple, actually using the R syntaxes. This is actually how it looked like in Stata. This is actually how it looked in SAS. Actually in SAS you have to do a data step, and you do it actually with the if and then statement. You also can try actually to do it using a select statement, but I think actually it's understandable what I have done here. This messy thing here actually is how it looked like in a European Excel version or Google spreadsheet formula space, actually how it looked like. This actually represent, this symbol here actually represent the column A that contains the age, and the N actually is the row where actually these things are located. So you have the AN and so on. It's very similar, but in Excel and Google Spreadsheet you have to use these if and or functions in order to this thing to work. Okay. Now actually I will do something very similar. We will have a modified recoding, but using the regex or regular expressions actually. You first start with a free text variable. You have some text pattern, and from that actually you recode variables, so you can actually classify or make sub-analysis and so on. So there are actually two text pattern recognition algorithm: the globe, that is a very high level and is have very little control, and the regex, that is the one that I will speak about, that is the regular expression, and it's available in R, Stata, SAS, and Google Spreadsheet, but it's not available in Excel. Of course, it's very complex, it's very low level compared to globe, but it's actually very powerful. Here actually have the documentation for the regular expression, the general documentation. I have three sources here. You can actually have the regular dash expression.info. You actually can take the 5 hours course using regular expression with Kevin Skoglund from lynda.com. Everybody have access to this resource. Here it's in your Karolinska staff member. And finally, the Wikipedia actually also have information about them. Now you can Google it. This is the specific documentation for the pattern recognition function, especially the regex, in different software. Actually, these are some of the functions using in R. The question mark name of the function is a classic help command that you can run in the command line of R. SAS, actually, you can read this Sugi PDF, and this another PDF in Stata, and they illustrate how actually work these functions in these two different languages. And Google Spreadsheet, I will give a description in the description of this video. So the stuff that I did, actually I will not show you at the end. I only will talk about regular expression. I will have some free text variable like this, the macroscopic findings and the microscopic finding in the autopsy, and actually try to look the location of the MI actually using a text pattern, but actually use the regex or regular expression recoding. But in order to do it actually properly, I use the I do a preliminary search for all of different part of the heart, and finally I do a manual recoding according to what I read in each different location. It's not complicated to do, and it's very easy to do. Okay, so what are the regular expression of regex? Actually, the idea actually to recognize pattern in the text, and it has two components. The one actually called the literal character component and the metacharacter component. I will explain it very quickly in the next slide. We're starting with the literal characters. I will try to do some kind of demonstration with art. You can use actually any kind of software, but you have the literal part, and you have these metacharacters, that are special characters required to do things in special meaning, and I will explain it later. So a literal character could be any number, space, tabulation, or any alphabetical signs. Although I write A to Z, actually could be any sign. Actually could be Arabic signs or special character or whatever, are literal characters, and they cannot be on escape. I will explain what it means later. Metacharacters. So metacharacters could be all literal if they are escape. So these are the metacharacters that you cannot use them as a literal unless they are escape. So in the next, I show an example of the literal characters. You have the capital C, lowercase a, lowercase t, only match with this expression here, but doesn't match with any of other expression that I showed here, although are the same letter, but they are different case. These literal characters are case sensitive unless the program actually, you order the program to ignore the case. If you ignore the case, all of these four string will match with this expression. Here actually show the same. This thing actually match with this, regardless if in the middle of the string actually will match. But it will not match this one because a different case, unless you order the program to ignore the case. Here actually the same. If it is ignore the case, actually will match both. But if actually it's the default, that's taking into account the case, actually they only match with the first exception, that is I am a werewolf with lowercase, werewolf in lowercase. This actually is a mistake. Actually, this Y actually shouldn't be here. So the escape metacharacter is a backward slash, but in R actually it's two backward slash actually instead of one. In SAS data is one, and in R is two. Actually, escaping actually means to convert a metacharacter into a literal character, or vice versa. So when I have two of these things, actually means one forward slash. But if you are in R, you have to write three of these things to mean one of these. The dot actually is a metacharacter, but you put an escape, actually it just means dot. The question mark is the same. For example, this expression you escape question mark actually means you question mark. When you have this expression actually that probably you have seen before, you have C colon slash user / my user, actually it match this expression here, and this thing are escape. So some literals can be converted into metacharacters. This sign here actually means a number, only one, and actually it won't match any number, 1 2 3 4 5 whatever, from 0 to 9. This actually matches a space. This actually match the end of a line. This actually match anything that is not a number. So it can match all of these things, but it will not match a number. And this is a word boundary. Actually, it say actually where actually are the boundaries of a word when you actually are constructing your regular expression. The wildcard is the dot, and each wildcard actually match with any character. So here actually have the dot will match with the space, they, and there. Actually all of them actually match with this expression, but it will not match with this there without anything, because actually this actually require actually to have something to match, or this one actually don't match either, because actually it's an issue with the capitalization. Even if I have space or something, it will not match unless you actually change the case sensitivity of the regular expression in the program. The capture is just a set of parentheses, and alone they are totally meaningless. They actually require other metacharacters to have a specific meaning. For instance, this A, actually it's a little a, actually match with this A. But if I put this A in parentheses, actually will match only A. The parentheses are totally meaningless unless they are escaped. If you escape the first parentheses, actually it will actually require actually that match the A in parentheses in that case. So the repetitions actually means that the previous character or a capture expression, something that is in parentheses, must be repeated. According to the symbol, in this case, when you have a star, it should be absent or it could be more than one time. The question mark means that actually should be absent or only one time. It's called an optional metacharacter. And the plus sign actually means that it will be at least one or more than one time actually is true. And we have this curly braces with an n actually is a number, 1, 2, the number that you want. It means that the previous character or capture expression should be repeated at least n times. So some example, A star actually matches with A, and also it matches with a blank string, because actually this actually is optional. So this expression Bob star actually matches with BO, because actually this B is optional. Also will match with BOBB, all in capital letters, and also this one. This a lot of B's actually is matched with this one. When you have a question mark, it matches with the same as before, but the only difference is it will not match if the B is absent, because actually this question mark requires that. No, it's a mistake. It will match only these two. It will match this one actually only will match this part here. When you have a plus sign, actually this thing is true. Actually, it's a mistake here. I will correct this thing. I have to correct this thing because it's wrong. Actually, this actually should be correct. Something like this, and something like this. I'm correcting instantly. Actually, an instant correction. Only this one actually. Something like this. Actually, that is correct. Actually. Okay, let me see. Okay, perfect. So now it's correct actually. Whenever a plus sign actually should be at least one. When you have a question mark, should be 1 or 0, but not more than 1 actually. Here actually in theory it could match actually, but we only match only this part, but it doesn't matter. Okay, finally, when you have these curly braces with a number, actually you have to be at least the number that you have here. So actually, since there's a 3 here, actually this B actually have to be repeated 3 times in order to match. If repeated 2 times or 1 time, actually it will not work. When you have a parenthesis and a question mark here, the question mark actually is properly saying that if this this part here, capture, is absent or present, actually it will match. Okay. Finally, the anchor actually states the beginning at the end of a character, variable, or string. Here actually this caret means that it's the beginning of the string and the $sign is the end of the string. So in this string, my house is beautiful, the following regex will match. My with this caret will match with this thing here, and also beautiful followed by a $sign will also match with this, because actually beautiful ends the string. The following regex match with a blank string. You have a caret followed by a $sign. It means that there is nothing between these two things, and the only thing that matches with that is a blank string. The brackets. Brackets means that everything enclosed in brackets except on escape, caret, and dash present diverse possibilities for a single character. Consider the following regex. SE in brackets EAT will match with C, writing this way or writing this way, or the word set. If there is a non-escape, actually it have another meaning that we explain in the next one. When we have if the opening bracket followed by the caret, it means that it shows all the different possibilities for a single character that don't match that character. So if remember that we have this thing, but now I arrow the caret, it means that now these 3 things that before match Now they don't match. And anything else that are beside these symbols, even the space, will match this regular expression. The dash represents a range of value following an ASCII table, or ASCII table. So when you have this thing, 2 to 5, it will match the following numbers, 2, 3, 4, and 5. But it will not match 0, 1, 7, 8, or 9. Here is only one character that actually is important, actually. When I write A to C, IA/C in lower character, it will match any word that have a lowercase, anything. When I write in this thing, actually, it will have any letter. Any letter will match it, except special characters like the and O signs in Switch. It will not match. And finally, this one, 2/-8, only match 2/8 because this symbol here is escape. So it means that we only match these three different characters. And finally, the alternation is something very similar to the brackets. But instead of having brackets, you have parentheses, and it shows different possibilities for something that is longer than a character. What I mean with that? Take a look of the expression. We have the C is like the, so in parentheses, we have these three different possibilities: devil, sweetest song, and deepest thought. And they are separated by this vertical line. In theta and R, the vertical line means or. In SAS, they have other meaning, but when you are using this regular expression in SAS, you have to use this sign to show the different possibilities or options that you can for this alternation. So this expression here will match the C is like the devil, the C is like the sweetest song, or the C is like the deepest thought. All these three different possibilities actually matches this regular expression. And finally, this is all that I would like to show you about the regular expression. Probably I will speak about what are the results using the different the result from the study I am doing using these regular expressions. So thank you, everybody.